Cool. Now it's time to say you lost a few seconds, and now we're here with the dog at the trail. Here you go. I'm so sorry, Pupperoos. Phaser Rooney. No biggie though. You're now here, and I can take the hell out of this jacket and hat. Totally. And my beanie on and a zip-up hoodie. Do not need these on at all. Friggin' warm for what it is. Alright. Should buy some water too and all that. Yeah. You should have. Anyways. Come on, Phaser. We're at a trail and we're gonna enjoy ourselves. Yeah. You go potty? Alrighty. Yes, you do. Amount of time to get here. Alright, so more feasible, high efficiency, high horsepower, torque engine designs completed. You know, standard turbine stuff style into like all compact with a basically hybrid. Adding in more air, because I can always add in a version of like basically air being fed into that design if I wanted to. But it's like also that barking dog kind of thing is also very good boy, Phaser. Yeah, very possible too, if I'm being realistic about it. So it means that that's an easy way to basically gain thrust as I add in more fuel, and that's basically a constant igniter flame. Also thrusting through the little nozzles that come in, because it's sealed for the turning, rotating valve compressor piston head thing, and then it's able to then continuously go through its one nozzle area. Like, no, because like both of them have to go into the central chamber. This is opening up. It's like that's combusted. It's like that central chamber is like nice and everything. Come on, Phaser, come on. I know. All right, he's trying to go back into the ding trailer. Anyways, let's see here. I open this bad boy up. Huh? What is that? Oh, there it is. Okay, come on. All right, so see here. So right, it goes into the exhaust area, and the exhaust area is really kind of like another chamber that I can just add that fuel in that area as an injector, which allows for me to continue the expansion. Plus, it's still adding a measurable degree of thrust, as it's a jet that's going and resisting into this chamber. So that's trying to force it open faster, but also gaining that speed and velocity of flow, which is the spin start in many ways. So then I can go a little further with that, because I can also do it in the fan blade compressor area after the effect compression has occurred, because it's like the barking dog is it's going to have to burn through that. So like that, I can add a little bit of fuel around that area if I get the right nozzle, kind of bump system. So like those nozzles, it's like, oh, I don't have any fuel to give you, kind of like a carburetor. You know what I mean? Yes. I have a lot of pressure, and so as a result, I'm not going to go in there. And I also have this valve that's preventing more fuel flow. So like you can try and get some things, but like realistically, what you trying to do here? There's no real oxygen. I don't really have a way to get in. You're really kind of preventing me from doing the thing you want me to. then it's like, here's a little valve opening. Oh, what the fuck, you bitch! No! That kind of thing. And then the wicking effect happens because of the carburetor effect, and then you still have a little bit of pressure in the fuel rail kind of thing, which is now the fan blade, which is also helping push it in. So the combustion also gets a little bit of combustion chamber kind of area, which is expanding into, gets a little bit more fuel after the effect, or after the fact, and then, but not much. Remember, you're running extra lean in the port injection side, which is just trying to create a combustion, and then you add more fuel in, which is still, like, even if you didn't add more fuel in, you'd still get a fairly good, solid amount of pressure, you know what I mean, that you can use. Then you add a little bit more fuel and a little bit more fuel in the third stage, and you're fully keeping a thrusting profile going. You know what I mean? Like, as the air is now pressurized, moving one direction, and creating that thrust, like it's interacting with the basin reservoir of air that's in the hollow sides of the reservoir that then got compressed. That ignited, it's opening up in one area, but then like that's also still got a little bit of fuel, sure, but not much. You know what I mean? It's mostly fuel on this side, right? But then that's going to expand it faster, sucking that in faster, squeezing it in faster, giving you a continued pump of pressurizing air that's quite got to be fast. It's got to be detonating alongside of the fan blades, leading edge, right? Then you can have a detonation. Truthfully, it wouldn't be deflagration, it'd be a detonation. Especially after that leading edge and compression part to the expansional chamber, as that then also races up, tends to, while widening and wanting to further and further detonate, it's gaining greater and greater degrees of speed using mechanical motion to gain a greater advantage. But of course, it's towards the center versus the outside. So while there is a detonation for sure of combustion, most likely in the either secondary or tertiary fuel flow area, you are most likely not going to do that in the first area, unless you get into a very high RPM range for the engine, which is still feasible and possible to do. Would definitely not say it's impossible, just that that's not really what I'm looking for. Detonation usually means I outpaced the RPM speed of the blade doing its compression. I'm looking to actually have that be not doing that. Okay, I'm like, that's why it's a thrust profile versus which has then got the bell housing to just capture it right there, where it's got like the little, compressor, fuller channeling thing, where they kind of squeeze each other in, which I didn't really explain, but I mean, again, refinement, other people, blah, 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 blah. To me, it's like, yeah, well, you didn't though. And I'm like, well, you're right, I didn't. But if you listened all the way to now, then you did. And so now you know that there always was that. What do you know? I wish I could have shown you. The video part is really, really nice, because like I could be like, yeah, here's my hand, it's doing this stuff. So that way you know that the thing with the blades does that. Versus like, oh right, yeah, no, I didn't get that from your voice sound effects. Well, anyways. really on you. Somehow become a daredevil and have a 3D landscape from a single microphone input. Okay, just do that, you know. It's easy. Totally being sarcastic. It's not. But you can do that. I'm just letting you know. You could eventually get there. Right. Anyways, moving on though. You have the effect needing to be contained. And so like the inflow squeeze is higher pressure than the extremely fast burn rate in the secondary or tertiary. That is, well, it's denser here, compressed more, higher pressure than over here. Then it's also going to make it basically resist further going into that area as well, with, you know, a basic shape design. So like that's an easy enough thing to do. They already do that for some of their detonation engines, from what I've saw or seen. You know, and then think about that further. Tertiary would be quite fast. I think you can get it on the second at the right design there, especially at the right RPM. It's like for sure going to be a much easier thing. Low RPM, I would be like, yeah, I don't know if we need to speed it up that fast. I don't think anyone would really honestly have to, because like if you're maybe unaware, maybe uninitiated, or maybe don't know the physics behind some of that, that speed is being captured as a thrust profile, but also the expansional gas is being captured again as a expanding profile, meaning energy input as well. So it's interacting on both sides. The rear getting pushed away and the front being pushed forward, you know, depending on the, right, yeah, right. Yeah, so like one side of the counter rotating is getting pushed and the other is being shoved forward. And so like that's a good thing. You kind of want that. So like that adds energy into the system both ways, which is more efficient. Also greater use of the speed at these lower RPMs, and then higher and higher RPMs become, again, more and more able to keep pushing because faster burning fuels are better, not air fuel ratio fuels nor speed. Acetylene would probably be a very nice fuel to have, if we're being honest, because it would for sure increase the burn velocity, detonation velocity of the gases if you were so inclined to try and make a turboprop more of a high altitude, or a, let's go with what you call that, helicopter. See, like a helicopter would be kind of like a really cool design for this, because like it would very easily, I feel, be able to nice hiking trail though. I was here with my mother once. I might actually be able to get the recording. I still have those recordings where she like basically just yelled at me and belittled me because I wanted to go a direction in my own way, and ended up getting back to the entrance, and she freaked doing that. Anyways, figured I'd come back with my dog, and I'm now in my own apartment. Hell yeah. Fuck yeah, puppies. Beezer. But anyways, right. So faster, higher heat though is the problem. Yeah. I suppose it'd be like an acetylene mix at the end. You know what I mean? Like you push in acetylene for the tertiary, most likely, to keep the, and then maybe secondary fuel combustion to increase the detonation velocity and the overall energy input into the rotation of the turbine. So, that, and typically because it's, less atmosphere and you're kind of having to compress it and deal with that kind of stuff, acetylene is usually a little easier to make that work because, first off, it's colder air, there's less of it, but then you're traveling faster. You kind of want the increased degree of speed for detonation because it keeps pushing both ways a little better, and the heat is going to be recaptured over time, and you're already traveling at a rather significant dimension travel RPM. What I mean is, it shouldn't travel word use. That's wrong word. Not use that. Right, but like the engine RPM is usually fairly high because you want that degree of measurable torque. Now we have a large degree of torque, but actually we can always up engine RPM, and which will also improve efficiency, but also fuel use. So, try your best to balance it out. But you also have cooling that is far easier as well because you're in a colder atmosphere and you're usually moving fairly decently fast. For a helicopter, 180, 200 miles an hour on average. So, depending on the altitude here, still fairly dang efficient. But then you also have to deal with very extremely high altitudes, which then turn into, so we're just sucking more air in. That's what we're really going to do. These become compressors. These exhaust and intake are just super hardcore. And that'll probably just be a gearing change, versus like workable motion energy, and you try and balance it out for like increased air intake to maintain overall engine performance with, maybe maintaining a greater RPM than you normally would have these helicopter ginormosities here called blades. I know, right? It's like, looking at that, and I'm not super okay that it's quite that way. Like, I look at blade, like for real, helicopter blades to me kind of annoy the shit out of me. First off, everybody knows they have these wingtip vortices that are garbo. Then there's a fuselage in the way. What's this fucker doing here? I'm resisting my whole fucking lift, bro. The hell? So instead of thrust, you're really just kind of like, but see, most people are like, you're barking up the wrong tree, if they know anything about it. And it's like, for me, it's like, you don't understand hyperfixation problems for people like myself. It's like, this is stupid. Who designed this? I mean, it's doing its job, but like, what the fuck? Like, this is annoying me. You can't do this or that or any of these other things. Like, this makes it far more efficient. And so then I kind of turned into it, the toroidal kind of shape that they came up with, recently, which that was also another thing I thought about back in the Chandler house my parents owned. I like, yeah, but it comes with these massive other issues that are fucking abysmal in a lot of ways. Like, way more mass. I don't want more mass. I only really need it in certain areas to not do certain things. And then, like, if I can just add that mass back in a different way instead of a toroidal way, try and get around this thing by just extending a screw design at the bottom, like a really low down, how they do with the, ailerons or whatever they are. They go down on the wings. I'm like, if I can just spin that and then kind of flare it out, then it mostly collects and spins outwards around the fuselage, creating a little bit of a pocket if it's standing still. And when it's moving, it tends to be able to be the right little moving forward, that is, piece on the front that you can extend with a basic hydraulic, ram type of thing. You got the fucking pressure for it. So you can then essentially have that covered and then turned into a vortex inducer that adds to the vortexing of the wind and Bernoulli, Vitruvi, all that stuff, with the wind that's expanding outwards around it in the rear behind that. But then this gets added to, and then therefore becomes less drag happy. Gives you your reduced drag moving forward. And then the tips, I always had the problems with these tips. These tips and I do not go way back very well. So I was like, how do I make this thing hollow? How do I make it use that hollow nature to create a greater degree of lift and separation between the two pressure zones? And then how do I make it then have the very tip and leading edge effectively create a proper vacuuming vortex underneath and above that are going to curve that vortex, that we're just going to put a T-slot on the tips, which are, I mean, to be fair though, it's a little more nuanced than a T-slot. Like a T-slot will work, but then I'm like, this oval doesn't not work. I'm just angling it and curving it slightly, and then putting those little bumps and fuller channel things and vortex inducers. It'll curve itself down to the wing area underneath. So it's hollow, structurally stiffer, because it's going to use the whole wing to support itself, because it has to use these ribs that are also air modifiers, I suppose, or whatever you want to call it. But they alter the air path. And see, now when it's slow moving, like just getting up and running, and it's not going to lift you off the ground, they are really just sort of not going to do that much. You know what I mean? Like they're just sort of there, right? They're just the same as anything else. It weighs the same as a regular blade, but then it's like stiffer, less flexy, less vibrating, less all that stuff already, which is already good. But then it's like, right, then when you add in this, they'll spin up, they'll produce the proper air movement that continues to gain a definite increase in its advantage on the moments of time it has to work with the air that's there, as it's coming from the top and front, respectively, most often, sometimes the rear too. But it'll work rear or any area degree on that circle and above, just not below. Because typically speaking, don't really want to do that. So, but all that's curved in. Yes. So yeah, we're talking more like a golden ratio spiral for that motherfucker. That then has like this. Okay, so the leading wingtip part is instead of a bifurcation or trifurcation, it's more of a whale bump, hole maker. So those are hollow areas, which then have they're still bumps. They're in the front. They're bumped. They're like a bump, hemisphere kind of thing, right? But I mean, those have little other fuller channel areas, again, because we're spinning it from outside in. Remember, you have to work with the air you got. So the top part is different than the bottom part in many ways. Remember that bottom. Come on, Phaser. The bottom part has to, in every way, only be added to after the leading, or shit. Give me a second. Come on, Phaser. Come on. Yeah. All right. So we're gonna do this step by step, because this is easier to do it step by step. where my initial, and then we'll just refine as we go along. Instead of just being like, here we go. You know what I mean? And then I'll deliver it. All right, so step by step turns into leading edge bumps. You need to have these, I guess, stator or flat, pieces that are above, but they're going to curve inwards. Okay, not just your standard curving inwards here. We have to do a very specific degree of change that is both faster in its slope angle and then slower depending on the area it is on the blades themselves. Okay, now these other areas here, ooh, that's a cactus. Lift that dog up. Okay, there we go. All right, so now that leading edge area, which is kind of bifurcating, is shoving its air down. Okay, it has to shove all of its air down. And then it's going to use the Venturi effect from the air that's also going from its separated state as the wing travels forward to then suck in that compressed sort of style. It's not really, but it's kind of is on the leading edge. Now that's going to go down and add itself and spread itself to make it more dense, effectively, which now creates lift, of course, which is what you're looking for in general for a helicopter blade design, but that can't be all. Okay, so you have to make these really fairly decently gorgeous looking little fins, effectively, that are just phenomenal at what they do. They produce lift. So before we get any further, here are these fins that are going to be vertically there in comparison to the horizontal blade. Now they also have their horizontal angle that is going to be there with a, depending on the RPM, instead of using a hydraulic or any of this, we're just going to be using air pressure. So it naturally pitch on the side fins that are on the vertical fins. Now what this does is it creates a baffle in a lot of ways, but again, you have to understand we're going to change these blade angles on this little thing so that way it produces the correct flow through, but also measurable degree of increased pressure that is not stupid to have to overcome with how much power you need to use it. So you have to understand that you have to balance that. Now the top part is going to have that curve be for those fins to be, and I believe more of the tips than the center area. Now see, the tips will ultimately make it such that it can curve with the oval golden ratio curve, as that will use the bumps and the filler, all that stuff that's on this oval kind of curve thing. I don't even know what shape that is really. It's a spiral for sure. It's a circle. It's a circle spiral. There you go. But that directs airflow to be captured by these bottom areas, especially by the next wing or blade coming in. And so like that will then redirect that spiral into a uplift, effectively. It sucks air in from the sides, pushes it underneath, makes it denser in that area, but only towards the middle to outer edges while still providing a lift profile because of the blade angle. Yes. Now, we also have to add in that is static. The main body area where those fans are trying to like curve it out from in to out away from the fuselage, just slightly. So you only need a little bit, you know, not looking to create a vacuum usually on this one. It's typically people need growth. So there's that part that most people tend to not like, like, oh, we air, stupid. Meanwhile, I'm like, yes, engineer, and they do things like love and you should laugh at that. That's totally a joke. I totally understand, but that is a human thing. I feel like I'm heard from some of them, but the point is like there's a little bit of error. It's not going to be a perfect system. I'm only looking to direct a little bit, but really what it does for me is it creates these maintaining of vortices that tend to statically hang around in that area, producing a measurable increase of pressure in that area, which is great because I have an engine there. Sure loves it, that old high altitude stuff tends to be a lot easier when I have air there, So, and the balancing act with the, intake compressors in the now other intake compressor that's providing a good lifting characteristic and flow rate characteristic, which is a thrust characteristic, because it's still going to provide a good amount of flow. But see, the thing with the flow part is like, how is it that it's flowing so easily? And it's like, it's all about blade angle pitch, which has to use the standard pressure problem. So like altitude and everything else, like how do you do that? And it's like RPM produces this measure of compression on a fixed flow rate of air through a cylinder. Okay, which is already going to be there. Cylinder is already there. The moment it starts moving, the cylinder gains pressure, and the cylinder also has pressure resisting it for its change. And you get the picture on, like, it's basically like kind of like a valve, kind of like a pressure regulator as a result of motion energy being imparted. Now it's then having to dump its energy out into the rear of these verticals. These verticals, of course, aren't all going to be able to handle all of the out. So what you have to do is you have a one directional release for the intake, basically, where it's going to kind of like suck it in and then stall, and then it's a whole series of chambers and tubes, effectively. That is going to rotate it, keep it there, but that means pressure. But that also means that it's going to bleed off into one area. Then the standard Venturi effect of sucking in other air that's there, creating a greater degree of pressure one way, and it wants to all flow that way. And then there's this lower pressure, which is trying to suck it in a little bit. It gives it a little bit of lift too, and then it tends to direct it outwards along with the blade design already trying to do this. So it's a little bit easier for it to do that. But again, it's one of those, it has to be very carefully performed or done, however you want to call that, because it's like, look, the tips and everything else are supporting each other. Like they have to support each other. And so they're stiff, like they've got these nice little supports that are going to basically support across the surface area and the, bones effectively inside, like an exoskeleton, but in combination along with the air pressure itself, helping create a outward bound pressure that helps to increase the material design strength. To a degree, you can't get something from nothing. You're also increasing blade weight to a point of, the air, in a vacuum, they're both the same weight. But like the pressure and the drag, and while it's still good flow rates and isn't having it hang around too much. It is there in the system, and thus means its weight and resistance. Parasitic loss, it seems like, except that parasitic loss, when done appropriately with reduction of the material in the right areas and number of fan blades or blades, helicopter blades, and then, or let's put it this way. For me, the best way I end up doing it is, this is going to be really fucking like a bird. I'm going to make it fragile. Don't crash. Never land hard to the point where you will get hurt. Never do anything, like these are the wing bones, effectively. These are really thin but very lightweight, strong materials, ceramics, with woven fibers of different ceramic metal component, stuff like that. Kind of metal, metamaterial stuff, sort of design that then also has a, for sure, fragility. Let's put it that way. Like, maybe you can get away with crashing, like you're maybe 10 G's and your blades might still be okay and so on. You know what I mean? You're not getting away with that. But like, also, you just had a 10 G crash, so not really probably the best, like, oh yeah, I know everything about that kind of thing. Like it's as in, like, I know how I'm gonna survive, and I definitely lived through this and all this, like, okay, sure, whatever, hot shot, but like, try not to crash. Your options are don't crash and try not to crash and survive a crash. Which two of those means you're less likely to have crashed? You know what I mean? So that's kind of where I'm at. But what it means is it goes off to the sides in standard basic, fan shroud for the when it's necessary. And the reason why I'm like hydraulic ram is my usual go-to is because, like, I have a lot of hydraulic fluid pressure. If I want to use it, then it's like, yeah, but then I also have the option of just being like, oh, I can just immediately shove that up. I can literally just be like, yeah, boom, it's up. We're traveling forward now. Let's go. What? Oh shit. Which, it's also one of those benefits because it's like it lessens its fan blade angle, and those vertical become like more of a horizontal, and the horizontal become more of like a capture for that horizontal, and so they kind of actually create a greater degree of forward, lift. When it's horizontal, you just trying to, float, hover, then it's like, oh, that's easy enough. For the most part, like, efficient. There's no fan shroud. There's technically lightweight, for like if a comparable design was just, all that solid thing. But it's just basically the same amount of weight, but then I also have my engine super compact, hyper efficient. So like, then that's less weight for right there. And then I've got my, fan shroud, which is like, I kind of add a little bit of that weight back when you think about it. And then it turns into, oh right, yeah. So, roughly similar, maybe a little less weight, depending on the materials and everything else, blah, blah, blah. Lots of caveats there, really. You have to design the whole thing and do it. But like, that whole thing tends to just mean, for me, it's like, here's a more helicopter. Like, because I was really getting pissed off about helicopter blade designs and fans and all this stupid stuff with helicopters. I love helicopters, don't get me wrong, but it's like, suffer from these major flaws that I at all leave alone. He's like, go away. And I'm, even this, right? see the rear blade thingy? You know, like the thing that stops me from spinning, round and around and around. Well, guess what? That's just a counter-rotating design, like both sides. And then I have a teardrop for that. Instead of one area, it's like I have it stuck because it's firing air in, because I can get it from the tail fuselage area, suck it in, and then blow it out both sides. And then I have a stronger degree of stability. And or should it happen to be necessary, redundancy. If one fucks up, I've got another. Which is not a bad idea. And even then, it's still like, oh, okay, I'll shove in the button and it does the shroudy thingy and it blows the air off both sides. And then I'll just keep going forward and that'll keep giving me a measurable degree of stability for a while. Go, go, go. We got to make it home kind of thing. And it's like, that's redundancy again, like, survive, bitch, go. I've got 4 of these fuckers. You fuck up all 4, you're fucked. Just land fast. You know what I mean? Right? Oh, fuck, yeah, and it's like, that's basically what the helicopter design kind of turned into, to a point. Really, because then I was like, all right, you know what? There's a really easy way to do this if I can just transition from vertical to a horizontal. And so vertical to horizontal became basically a version of this kind of helicopter blade and design, to then it tucks away, and I just have wings come out, like little stubby little wings. And by tucks away, this it goes together with the wings, and they kind of are sort of. Yeah, I know. I changed it a little bit. Before it was just like it's just going to be straight rear, and then like in line with the fuselage, and then intake with the nose area for the fuselage, and then shove it out the rear with thrust, and here's some stubby little wings. You know what I mean? I was like, this is kind of scary, actually. It works, but it's like, yeah, really. I mean, that thing will work fast. Oh boy, does it! Junk. It's like, you are falling. Yeah, well, it's fine. So it basically dumps, and I mean this, dumps the all of the momentum and flywheel energy that's in the central area, kind of piston, rotating, all that stuff that I was using to make the power be delivered either to the thrust jet engine type in the front of the nose to the kind of fan blade turboprop or whatever at the top. And so if I do that, it's like, it's nice, cool, easy, seems like, right? Kind of. It's like, it's hard on the system, and that's why I use hydraulic fluid. Whereas like, oh yeah, no, it'll go and dump the hydraulic fluid energy into it, slowly take some time, and then it gets, the hard metal pieces to do its thing, which is good. You're kind of looking for that, so that way it doesn't break as much, but still, it's like, rotate immediately, open, close, start spinning. What the heck? And so that's kind of that from being really, really fun. But it's also like, you're dropping. You're going to drop during that. Like, you have some time before you're going to do that, while the jet engine basically dumps its energy and you don't have thrust really as much anymore. And so like your stubby little wings need to like super freaking hardcore try and flare, bitch, flare. And then it's like, then this rotates and you get the picture, right? But like stubby little wings, easy enough. All of it can be done fairly fast. Click in, use the momentum to basically squeeze itself to a for a pneumatic and baffled with a hydraulic, which will then try and reuse that energy into spin motion for something else, trying to help it start up the engine for the jet engine part, compressor, all that stuff, or the result of top, big old boy fan blade stuff. But then I was like, yeah, most people tend to just land. And from my understanding, like it's a fairly terrifying experience because like you hear everything go, and it's like, oh, it stayed stable. How the fuck? It didn't flip or anything. Barely. I know it basically uses a bunch of opposing systems to balance itself out like you walk, like one side goes back, the other side goes forward kind of thing. You kind of fall forward. It's using the fall motion to pretty much make it so it stays balanced and gets things spinning enough to not to worry as much. All right. Let's go back a little bit here, puppy. All right. But yeah, it works, and you only need about 500 feet roughly to get it to the point, depending on altitude, winds, and all that, to start the hover process again. Still, it's a fairly involved, terrifying experience for most people because you free fall for the 500 or so feet as things start picking up and spinning, and usually people are super excited about, I hit the button. Is it gonna work? It's working. Don't worry. Oh yeah. Ah! It's a little terrifying for most people, even my own self as a designer and creator. It's like, yeah, no, I know it'll work. It'll be fine. That being said, terrifying. Come on, Phaser. To a large degree, although people will do it and it'll be probably just fine for the most part. Like if anything ever fails, there's multiple redundancies. I'm always that guy. If you don't know, it's like, no, I'm not dying. Fuck you. Here's like 4 redundancies for your one fucking working thing. It means wait, right? Yeah, it just usually means it bypasses to something else. But mine bypasses into other systems because it's easier in all aspects. It just bypasses into another system. Really? Yeah, like, oh, it broke, or it's not spinning and it's stuck. Oh, it's okay. Once it builds up that pressure, whoosh, goes right over there. This valve or whatever else, it's gonna keep fucking doing it. You know what I mean? But like, you only got 4. Okay, I see what you're saying. Like 4 is pretty good. Like, dude, come on. Like, granted, yes, there is more weight, but like, not as much as you expect. You know what I mean? It's like it's about the same amount of weight. It's just the tubes and bypass and all the kind of like just that. Now, granted, it's like any other design where you have to, I don't know, fly in the air. Usually they're not fragile. That kind of thing. Oh no, there's a dead bird over there. Let's not touch that. I think it's a crow or a raven dead over here in the woods. Yeah, it's one of those. It's definitely a black bird. Definitely not a pigeon. Nope, nah. Come on, Phaser. Not having you smell that. I know you wanted to slowly work your way over there, try and fucking get me to give you a chance to play around with that thing. But I hope you had a wonderful life and everything was good there, dead bird. Okay, now back into the change of this design, because terrifying, and I think most people in all aspects besides maybe even military might not even like it, are really just like, no, please don't. I'll just take a regular helicopter. It's fine. It's A-okay. Let's just do that. Helicopter. Yeah, just regular ass freaking helicopter. Versus this, yeah, okay, yeah, you know. And it's just because it's terrifying. The transition going to lifting characteristic forward, sort of style, like a regular airplane, is far smoother. Like you basically don't really even notice, because the wings will start to lift around that point, and then you kind of just sort of lift and keep going faster with a transition over to the engine, picking it up to being more of a jet engine style exhaust, all that thrust and turboprop stuff. But the transition from that to the big boy blades are a little bit rougher. So that's kind of what that is. But where was I going with this? Right, I had a different design. So this is why the toroidal, or not toroidal, but I guess it's slightly like a toroidal design. The one I was just talking about was the helicopter design that I kind of concept designed back in the Chandler house a while back. And then it was like, I'm going to wait till here to talk about it, because I predicted all this other stuff being the case. Like, we're apparently in a wormhole computer and a bunch of bad negative programs that basically refuse to let do anything or change anything or come in and that kind of thing. Moving on, we're going to get into the new design, which is not just a much better helicopter blade kind of thing, which is just like a screw, if we're being honest, how it kind of works. Yeah. We're now going to start with the airplane thing. Yeah. It's literally kind of basically what it is, if I'm being honest. I'm not even kidding. Let's see here. Airplane. How do I describe this? Because it's always kind of annoying, when it comes down to like, how the hell do I figure out this stuff? Like the word thingy. I had a thing in my head too, and so now I'm trying to remember that part. Let's just start where we're going to start. So let's start at the basics, where I really kind of thought about it and then I refined it into where I know it is already. F-35 has a rotating nozzle that shifts downwards, that helps it hover. And I was like, I can basically make that like a Harrier jet too. You know what I mean? There's nothing that says I can't, technically. But then I'm like, it's kind of stupid. And I have these things called like wings. And I can just block its, energy flow outwards towards the rear, towards more downward spread out position. It equals the same amount of surface area for thrust throughout the wings. And then that's where it started becoming the project that I eventually got to, where I feel like I'm pretty done, with it. So the wings are kind of like those, older style built-in jet engine things. But instead of a built-in jet engine, it's underneath, and it's really more of a kind of branching tree design where it creates a consistent, constant thrust that has a nozzle change, and just like the mainsail engines on a rocket ship, the ability to create a bell end and capture more of that exhaust energy and thrust. But I also needed to intake a little bit more for that Venturi effect. And so I made a YouTube video on Xenon Reality, my YouTube video, that is a literal, hey, Antexa, your Dyson fan blade's cool. If you do this, you can just basically make a really, really strong jet engine type that uses the Venturi effect with a Bernoulli effect to create a version of rotating gas combination mixtures that then has its ability to gain a degree of fuel that then expands and interacts with the bell end housing, which provides a degree of thrust for you. And the faster you go, the more efficient it becomes, like any ram air kind of style, but it's not ram air, not until you really get fast enough to be able to do that. So it's kind of a style like that where at first I'm just adding in air. You know what I mean? It helps cool the bell end area. It mixes a little bit. I can add a smidgen of fuel. I can extend the bell end, and then I'm able to essentially have multiple jet engines carry me. Okay. Come on, Phaser, I know. You always want to be carried once you really take a chance to get a big old walk, but you're a growing puppy, so you'll survive. But we'll get into how, like, it's not really a wonderful design. So as air is coming from the intake for the jet engine, it tends to have that same Venturi effect, as it tries to suck in more air, because it's got a lower pressure zone and now it's got a higher pressure zone, right? Right, and that provides a little bit of lift in and of itself, and then it's getting sucked down, which provides an even greater degree of characteristic of lift. And then the heat expansional properties, because of course it's now providing a greater and greater degree of outward flow, produces more and more suction. And so you gain more degree of lift, but not to the point where you're going to fly. Okay, like it just makes it more efficient. Come on. There you go. I get you. You want to... No. You got to... We're almost there. Come on, Phaser. All right. So this rather extreme effect, which is, pronounced, and how significantly it'll keep doing this carburetor wicking, dragging in, then thrusting kind of effect, sort of style, which is also another reason why it's like it needs a pre-chamber. Okay, so I'm mixing it with a pre-chamber that is then going to be basically like a standard Tesla valve that does this sort of, effect. So I have a double Venturi system that's having to be on the wings that I have to add a basic fan shroud, kind of like just cover and goes over it once it gets up and going. Now the effect sucks. I'm being honest, I burn a shit ton of fuel, as everyone knows, on anything like this. But it's like the double Venturi is kind of like, well, the first part mixes with the exhaust gases from the first input of energy, which is the jet turbine. Now that jet turbine, cool and all, but that, can only provide so much until it's no longer able to really keep providing. And so the next part is the added air and fuel mixture for the secondary Venturi system, which of course is now a huge plenum volume, basically. And because that's a longer tube and therefore has more air mass flow, respectively, because of that, plenum volume has a higher degree of heat, and you shape the chamber to basically be more resistive to going into that or back into its mixing area state. You gain a significant continuation of continued speed, basically. It's higher heats, burning more mass. We have to shove it into a smaller space. So then that smaller space has to have a tube that's fairly decently long and then slowly spreads out for a bell end to atmospheric pressure to gain maximum advantage. So I have hydraulic rams. I know, right? Like it's about hydraulic rams. That's just really fluid flow more than anything. Once it gets up and going, the jet engines, more or less, it's produce the hydraulic fluid pump action that spins the next shroud down over that next area for a tube over a tube. So that tube then makes the atmosphere at your standard usual altitudes within the 0 sea level to about 1,000 above. And then that secondary tube is also the helper to a large extent for creating that resistance for the secondary mixing chamber for the Venturi system. And in the let's see here, basically Tesla valving baffle system that heading back effect is essentially into the Venturi system, and also mixes it in a much faster way, so that way it's able to, with the fuel that's getting pushed in with that Venturi system, then slightly just helps itself wick in like any carburetor air fuel kind of system would do, but it is also less pressured than the inside. Then it bounces and kind of needs to create, because it's a never-ending kind of shockwave sort of thing, and you have to create these not vortex inducers, but not a terrible way to put them. Like double vortex inducers, a kind of way to put that, where it's going to mix within that burn, shockwave bounces, thrusts, and that shockwave into the other burning outward flow vortex that then also has its own version that goes into the initial exhaust area, then combines and effectively cancels and provides a forward cancellation, meaning it creates a spring that then sends the spring is not a good way. It's more of a whirlpool golden ratio kind of design. Fair point. Yeah. It's just air pressure like a spring, typically. But it goes the direction of the thrust you want, which is great. Let's see here. That in the compression further creates a vacuumy kind of area for it to continue drawing in greater degrees of air and fuel and mixing it and continuing to combust it. And so as it continues to burn, essentially, while it was initially somewhat compressed, it then became much more compressed by the end, and where the bell end housing is finally going to then give it actual thrust that's with all the jet engines you kind of need for it, and the fuel you have to burn, something that'll lift you up. And that's the passive system. And I was like, instead of burning all this extra fucking fuel, giving it length and duration and all this, fuck this. I then just made that a turbine sort of thing, or hydraulic fluid. Like, I have the hydraulic fluid, why am I not using this? So it's like a ring style Venturi system, meaning like I have a fan blade at the top with the Venturi system, the double fan, Venturi system that is, which yeah, I know, right? It's a hydraulic fluid, which then has to spin, and that's a pump, and so I have to spin the fan blade, which is a series of fucking stupid ass fan blades, which is like I have to suck in a lot of air that's already trying to move, and I have to capture the stupid sucker, cause a rotational, bend in the damn thing, and then vortex it properly with the blades, so that way it fires faster and more efficiently into the system, and then I can pressurize it by effectively putting it into a smaller volume. And then once the smaller volume is there, I just need to put a stator baffle, whatever thing that's then going to be like a teardrop shape that then makes it so that way it is compressed, and it is then going to, on the trailing leading edge of those wings, add in fuel, because it's a kind of a low pressure zone, and it'll work away into the chamber where it adds itself to the exhaust, which then increases vortexing degree and combination of the two exhausts. I'm not two exhausts, come on. Now, two exhausts then will effectively, that's a good way to put that. Yeah, well, we still have to get the basic teardrop shape design. It's like, what? Yeah, well, Tesla valve teardrops, several teardrops that are, anyways, point is, that's also where that pressurized system is not so far bifurcated. Remember, you have to have two of them. So the first is hole in the center, then has a secondary outward donut intake. And so that bifurcated hole in the center then gets added to with the outside ring donut intake, which is also spinning, its own little thing there. Then that gets added to it itself. Combustion then gets squeezed, and then this adds its own version of a wonderful and beautiful jet, effectively. It's kind of like a version of a fuel and air detonation jet that obviously pushes in towards the center and then rapidly burns up to the nozzle, but the nozzle is flowing it fast enough that it can't get to it, but then also that further squeezes the exhaust gases and mixes them and combines more or less and dissipates like the standard double vortexing system we were talking about before, that will then dump that energy into forward momentum, forward travel, that is put through a small little nozzle tube that, of course, is cooled by the fuel and hydraulic fluid, respectively, so it doesn't die and burn to death. Effectively make a oxyacetylene torch for where it is. It's a very high pressure system that normally would never survive. It's only because of that damn secondary burn that it produces anything like something like that, where it squeezes it in through the nozzle and it just happens to slip through using the vortexing and the nice little channeling, and that is also where the cooling tends to happen and tends to realign and force the exhaust gases to give up spin and vortex for speed flow travel as they expand into the now bell end, which, of course, as you have intake one way, an intake on the top, and then a very high pressure system on the bottom, you gain a great advantage to the design of the system, standing still with wings that allows for you to do the basic lifting body characteristic from a standstill. Granted, you're burning energy to do it, so that's kind of what that is. And one jet engine is literally doing all the work of the intakes. So like those exhausts are just turning into thrust, which is fine, but there's a reason for that being only just exhaust. Yeah. Ooh, shit. Okay. We're gonna go up this way. Come on. Is this the one, or is it? We'll keep going if we have to. Yeah, I'm almost back, I think. Yeah. Whew. There's my bike. There we go. That's right. Sweet. All right. So, but the exhaust is basically a almost near example of a very effective and efficient use of turboprop to thrust for a jet engine design that allows for a lifting characteristic from the wings to be amplified. And again, it's one of those sort of because I need to have the nozzle be able to bend, and change, characteristic. I need to have it shrink back into the wing area, and then the teardrop shape kind of the wing area, sort of towards the rear there, has to also survive the jet engine's exhaust, which has to still now be redirected underneath it, but also at that tail end too, where it's now going to become a measurable degree of Venturi effect, which is wonderful. It makes it more efficient. As we all know, lifting anything straight up is less efficient than using momentum moving forward to do it with the pressure differentials in our atmosphere as a result. But this one tries to get it done by cheating for that very principle using Venturi. Good old Italian guys. Am I right, folks? These guys got the Newton, got the Bernoulli, got the Venturi. These guys know what they're doing for fluid, it seems. One could say about other things there too. Seems like they enjoy a fluid exchange sometimes. Know a thing or two about that. Anyways. All right. Now we're going to talk about how this design has a massive problem, even if it is fairly somewhat something. Like it's a start. That's for anyone that's wondering about. It's a start. It's because there's, sure, there's a lifting body characteristic, which cool, you know what I mean? Right, yeah, but there's also a massive inefficiency problem for the Venturi and extra turboprop thing and all this other shitty shit that sucks, you know? Good boy, Phaser. Good boy. Sorry, gonna have to close your out. No, I know. You're gonna have to, though. You're gonna have to close the thingy and keep you in the trailer, all right? I'm gonna have to also change my recording. So give me 1 second after I'm done with this. It's okay, Phaser. I'm right here. All right. Right. And so this thing suffers, even though it has these systems that continuously try and increase this effect. It's not that increased because I'm not forcing it to be even faster. I'm using pressures, sure, and increasing the pressures using active profiles, yes, and then amplifying it by using surface area, increases and increased degree of thrust characteristics as a result of those surface area characteristics and a gaining again of efficiency from that. Phaser, I'm right here. Phaser, it's okay. We'll get going soon, all right? It's still not, in fact, the right kind of thing. Like, remember, I started off with like, yeah, I know, I started with this. This was my base level design. It's kind of shit, so in rough, but like, give it a second, that kind of thing. And it'll work, good enough, I suppose. But that's where it stops, being a thing kind of thing. You know what I mean? That kind of thing. All right. Back to recording in a little bit.